I can identify the corresponding angles and sides of congruent triangles. So the vocabulary we're talking about here, congruent segments. Congruent means identical or equal. So for segments, we're talking about the same length. For congruent angles, we're talking about the same measure, same number of degrees. In congruent figures, whatever those figures might be, we're talking about the same shape and size. Now there's a fancy phrase called corresponding parts. Corresponding in this context means matching, so matching parts of congruent triangles, of identical triangles, are congruent, are identical. Stop and think about what that means. If you've got two congruent triangles, then you know each of their matching parts also have to be congruent. So if we come down here, the key is to look at this statement. The order tells you everything. If you look, for example, A is the first letter here, D is the first letter here. That means angle A corresponds to angle D. B is next, and it corresponds to E in the middle on the other. So B corresponds to E. I'm going with a single arc, double arc, and then I'm going to go with a triple arc system. You also instead could put a single arc on each of these and a single tick, double tick, triple tick. It's up to you, they mean the same. If I were to use three letters here, I'd say angle BAC, A being the vertex. Notice I went BAC here. I went 2, 1, 3 with the arcs. Order matters, so I have to follow the same order. 2, 1, 3. I have to say E, D, F. Now, you could just use single letters here because they're not sharing a vertex with another angle, but we'll stick with three letters for right now. How about we go to, after one arc, let's go to two arcs, and then we'll go to three. Two arcs, we're going to go with B will be the vertex. So I'll say ABC. What corresponds? DEF. Again, they got to match the order. Finally, let's go with three arcs is angle C, or rather angle ACB, DFE. Now, you'll also notice that if you just take the first two letters, AB, they correspond to the first two letters, DE, in the other triangle. I say that because segment AB corresponds to segment DE. And the next two, BC, corresponds to EF. So segment BC corresponds to segment EF. And finally, look at the first and last. AC is to DF. So segment AC is to segment DF. I'm going to mark up a picture. 2 ticks, 3 ticks. Single, double, triple tick. Order, order, order matters. Okay, let's come down here and check out this one last time. You can hit pause and try and fill in this table. All right, here I go. A corresponds to D, so I'm going to say angle A is congruent to angle D. B goes to E. And C goes to F. All right, even without the picture, we can just tell real quickly. Next up, AB goes to DE, segment. BC goes to EF, segment. And AC goes to DF, segment. You can sketch pictures if you like, but the order tells you everything. Let's talk about the converse. Instead of saying two triangles are congruent, so their corresponding parts have to be 2, let's reverse it. If the corresponding parts of the two triangles are congruent, then you know the triangles are too. So take a look at the diagram. Let's pull the information. Why don't we go ARQ? Triangle ARQ. Now look, A has 3 arcs, R has 2, Q has 1. You have to go in the same order. This is particularly important if we start spinning or rotating this, and it's harder to match up the corresponding parts. So I'm going with a 3 arc, 2 arc, 1 arc order. So I have to do the same 3 arc, 2 arc, 1 arc order, PTG. Also notice how A was between a single tick and a double tick. What does A correspond to? P, because it's between the single tick and the double tick. That's another way you can tell if those arcs aren't there. When a conditional statement and its converse are both true, we call this biconditional. If you remember any one thing, order matters. Good luck.